Fast forward to 2035. India's economy has crossed the $5 trillion mark, and the infrastructure demands across the country are staggering. If you are an engineering student right now, you are likely hearing the same warning on repeat. Artificial intelligence is going to wipe out traditional engineering jobs, leaving new graduates with useless degrees. This graph shows employment projections over the next decade. The flat line represents traditional, routine engineering jobs, like basic coding and drafting, but the line shooting upward represents AI-integrated roles. Data shows engineering isn't dying. Demand for tech-driven roles will actually grow significantly. What is dying is the role of the specialized executor. To thrive in this environment, you have to become a domain expert integrator, someone who understands how to use AI, data, and sustainable technologies to solve complex problems. Because of this shift, looking at a college's 2024 placement statistics to choose your branch is a trap. If you optimize for the easiest entry-level job today, you risk entering a highly automated, oversaturated market by 2030. Computer science engineering remains the most demanded branch in India. It feeds into IT services, product companies, and fintech. But the assumption that a CSE degree guarantees a high-paying, easy entry-level job is outdated. Generative algorithms are actively automating the most repetitive parts of the software lifecycle. That includes basic syntax writing, repetitive code generation, and routine software testing. This diagram shows the required skill architecture for modern CSE graduates. Pure coding at the core is no longer enough. You have to integrate 3 distinct layers: system design, cloud architecture, and data science. When you add these layers, the job market opens up. Global projections show a 15% or higher growth rate over the next decade for roles that require human engineers to design systems and integrate cloud and AI tools. Memorizing coding syntax to pass a basic technical interview will not protect your career. You have to trade basic execution for architectural problem solving to secure those high-paying roles in product companies and deep tech startups. Electronics and electrical engineering branches sit at a highly advantageous intersection. They form the physical bridge that connects hardware infrastructure to digital AI systems. For electronics and communication, or ECE, demand is being driven by heavy investments in domestic semiconductor manufacturing, the national 5G rollout, and the expansion of IoT. IoT stands for the Internet of Things, which refers to networks of physical devices embedded with sensors and software to exchange data. Electrical and Electronics Engineering, or EEE, maintains stability through the massive capital flowing into renewable energy infrastructure, electric vehicle manufacturing, and smart power grids. Taking advantage of this demand requires a steep learning curve. You must understand tangible hardware logic like embedded C and control systems, while simultaneously mastering software tools like Python and Edge AI. Edge AI means running artificial intelligence algorithms directly on a local device, like a smart meter, rather than in a distant cloud server. This dual mastery of hardware and software acts as a highly effective career moat. It is incredibly difficult for purely digital algorithms to replace engineers who can build the physical infrastructure that the AI runs on. The traditional core branches are facing a harsher reality. Mass recruitment into standard, site-based civil management or repetitive mechanical drafting roles has heavily slowed down, and entry-level pay is often highly variable. The reason for this slowdown is the rapid adoption of simulation algorithms. Tasks like basic two-dimensional CAD drafting and standard structural analysis are easily handled by modern software suites. For mechanical engineers, the upskill path requires moving away from basic manufacturing and into robotics, advanced materials, and digital twins. A digital twin is a virtual model designed to accurately reflect a physical object, allowing engineers to run simulations before anything is actually built. Civil engineers must master Building Information Modeling, or BIM, along with geospatial technologies and environmental sustainability regulations. BIM is an intelligent 3D model-based process that gives architecture and engineering professionals the tools to plan and manage buildings more efficiently. Entering a core branch is still a viable strategy for a lucrative career, but only if you immediately abandon the idea of being a generalist. You must commit entirely to learning digital modeling and automation integration from day one. Beyond the specific branch you choose, the ecosystem where you earn your degree dictates your immediate opportunities. Top-tier institutions like the IITs and leading NITs provide exposure that average colleges simply cannot match. For students in regions like Kerala, this presents a specific geographic choice. balancing the convenience of state colleges against the rigor of national tier institutes. Local premier institutions like NIT Calicut and IIT Palakkad consistently report median packages in the double-digit ranges. Their environments mandate project-based learning and industry partnerships that standard local colleges often lack. This brings up a critical trade-off. A weak computer science degree from a low-tier college with poor faculty and no industry connection will leave you highly vulnerable to automation. Conversely, a strong poor degree, like ECE or EEE, from a premier institute provides a massive advantage. The peer network, advanced labs, and fundamental academic rigor found in a premier college give you the foundation needed to pivot into tech roles later. That environment heavily outweighs the perceived safety of picking CSE at a lower quality school. This diagram shows a structured 4-year upskilling timeline designed to bridge the gap between academic theory and actual industry demands. Notice that Step 1 covers your first 2 years. Moving to Year 3, you enter the skill-building phase. This is where you combine your branch-specific knowledge with external, high-quality certifications in cloud architecture or data science. Finally, Step 3 in your 4th year is the portfolio phase. Generic college lab files will not get you hired. You need to build and deploy 3 to 5 real-world projects that actually solve a problem or analyze a complex dataset. During these first 2 years, you must secure your foundation in core math and physics. More importantly, learning a programming language like Python is now mandatory across every single branch. Surviving the transition into an AI-heavy workforce requires a serious trade-off. You have to sacrifice unstructured college downtime for a continuous, highly disciplined cycle of self-education. If you are a logic-driven problem solver who naturally gravitates towards software, computer science and IT are still your best paths, but you must focus strictly on systems architecture and cloud integration, not just writing code. If you are a hardware builder who likes to see physical results, ECE and EEE offer the safest physical world moat against software automation, provided you learn how to program the hardware. If you have an infrastructure mind focused on large-scale physical design, mechanical and civil engineering remain critical. Just remember the absolute necessity of adopting modern digital simulation and management tools. Here is the ultimate rule for the 2035 engineering landscape. Artificial intelligence acts as a massive multiplier for the expert, but it acts as a direct replacement for the novice. Do not attempt to compete with an algorithm on repetitive tasks. Choose a branch that aligns with your natural aptitude, master that specific domain deeply, and become the engineer who integrates AI into the real world.